If you want to survive as a creator today, the rules are strict. You pick a niche, you establish a recognizable brand, and you hyper-optimize every title and thumbnail to feed exactly what the recommendation algorithms are hungry for. Then there is David Brilliman. He runs a YouTube channel called Media Farts Productions, a name seemingly designed to repel any attempt at traditional marketing or brand cohesion. A quick look at his feed reveals a jarring level of juxtaposition. You will find a calm 9-second clip of a great blue heron stacked immediately next to a dense academic lecture on AI epistemology. Keep scrolling, and you will see internet memes and quick jokes placed right alongside serious explorations of psychological frameworks. To a traditional digital marketer, this looks like a disorganized, failing content farm. But this archive actually exposes a specific limit in how modern recommendation algorithms attempt to read human intent. This chart shows the extreme mathematical disparity in the channel's viewership data. We have a massive viewership spike of 2,800 views for a simple video of a great blue heron, while the dense philosophical uploads stay between 80 and 150. Traditional YouTube logic dictates a very simple solution here. The creator should immediately niche down, abandon the dense lectures, and only produce heron videos to scale the channel's reach. But we have to consider if the algorithm is misreading the data entirely. These high-performing nature clips and the low-performing theoretical lectures might not be disjointed failures competing for attention, but rather interconnected layers of a single architecture. The current data captures a spike in interest, but it offers no hint as to how these disparate uploads are actually connected. To find that connection, 3 independent AI models, ChatGPT, Gemini, and Grok, were fed the channel's data and tasked with analyzing the seemingly chaotic feed. All 3 AI probes bypassed the surface noise, ignored the varying view counts, and converged on the exact same underlying pattern. They identified that the channel is actually a living digital commonplace book, a public field notebook driven by one recurring theme. Every video, whether it features a turtle, a river, or an artificial intelligence, is asking the same exact question. How has meaning emerged from complex systems? The fact that 3 distinct artificial intelligences independently found this same pattern suggests the archive is the highly deliberate project of a systems thinker. The structure relies entirely on somatic droplets. These are pure, unmediated pieces of raw nature, like a heron or a river, that require zero systemic context to understand and enjoy. This solves the problem of algorithmic friction. When a creator drops heavy concepts, like Carl Jung's abstract psychological frameworks, onto a feed, a general audience usually bounces immediately. This diagram illustrates the gateway logic. The wide opening at the top represents nature videos acting as physical anchors to bypass algorithmic resistance. Once this visual baseline captures peripheral traffic, the system pulls the audience downward into deep structural lectures. Direct observations of nature provide the necessary grounding for an audience to navigate abstract, recursive systems. Short-term view counts and algorithmic spikes measure the weather. A systems thinker is building the climate, a long-term accumulated body of work. Those videos with only 80 views serve a specific purpose. They function as a decentralized lecture series for a dedicated core audience who wants to understand the architecture of the ideas. And here we find the ultimate irony of the channel's data. The highest performing, widest reaching piece of media in the entire archives, the Great Blue Heron, was the least authored, least optimized piece of content. It is a perfect demonstration of Wu Wei, the action of non-action. The heron video shows that authentic, unpushed observation naturally travels further than forced narratives. True intellectual value is built by documenting unforced observations of the physical world and using them as mirrors to understand the complex systems we live inside.